Okay, here comes problem number 17. This one's going to be calculator, so we don't have to show much work here. Find the displacement, s meters at time t seconds, given by, okay, so here's our displacement. Write down the minimum value of s. So I'm going to go ahead and put this into my calculator. So I'm going to put in 5 cosine 3t plus, oops, I got to watch out for my parentheses, close my parentheses, plus t squared plus 10. I'm going to graph it. Notice my window is still set for the last problem, so I'm probably going to have to adjust this. It says t is greater than or equal to 0, but I can't see it very good, so let's do it in 6 and find out where it's at. And then I want to find the minimum value of s. Okay, well, I can see the minimum value is going to be right there. So I'm going to do second calculate. I want the minimum. And where's my cursor? There it is. So I want the left of it, go to the right of it, enter, enter, and I get the minimum value occurs when x equals 1, and the minimum value is 6.05. So minimum value is the y value. In this case, we have the letter s. So the minimum displacement is going to be 6.05, and that would be meters. Okay, find the acceleration at time t. So to find the acceleration, I need to find the second derivative. Okay, so velocity is the derivative of s. So the derivative of s is velocity, and then the derivative of velocity is acceleration. So first I'm going to have to take the derivative here of s. So I'm going to write down my s first, take that derivative. So my velocity is going to be, keep my constant. The derivative of cosine is negative sine. I'm going to put my negative out here, so it will be sine 3t times the derivative of 3t would be 3 plus t, not a, and the derivative of t squared is 2t. Derivative of 10 just goes away. Wow, I have a lot of students coming in. I'm videotaping right now, so I can't talk to you, okay? Go ahead and grab a seat and get on that space. Okay, so now I need to take the derivative of this. Actually, let's clean it up a little bit. That's negative 15 sine 3t plus 2t. Now I take the derivative of that to get acceleration. I keep my constant. The derivative of sine is cosine. But since I have something happening in here, I need to multiply by the derivative of that, which would be 3. And the derivative of 2t is 2. Simplify that. I get negative 45 cosine of 3t plus 2. That's my acceleration. Okay, so I have my acceleration function. Find the value of t when the maximum value of a first occurs. So I'm going to use my acceleration function. Acceleration is equal to negative 45 cosine 3t plus 2. And it says find the value of t at the maximum. So I'm going to put this into my calculator. So I'm going to have negative 45 cosine of 3t plus 2. I'm going to graph that. Whoa! That's pretty crazy looking. I'm going to have to adjust my window once it's done doing that. Okay, so the first maximum is going to be occurring over here. So I'm going to go to my window. I want my first maximum. Let's put in negative 1 to 2. And my y scale, it didn't look like it was going up enough. Let's put it 30. Let's see what happens there. See if I can see the top yet. Oh, okay, so my x values are looking good, but the maximum is still off the screen, so I'm going to do that again. Let's make it the 50. Let's see if we can see the maximum now. Actually, I can tell that my maximum is going to be somewhere around 45. 45 plus 2 is actually probably 47. When it was 47, it's going to be my maximum. So a choice of 50 on my window was a good idea. As I see, I can see my amplitude and my vertical shift here, my acceleration. Okay, so find the value of t That would be my x value at that maximum. So I'm going to do second calculate. I'm going to do maximum. It says go to the left of the maximum. Here's the left. Enter. Go to the right of it. Enter. Enter again. And the x value is 1.05, and the maximum is 47, just as I expected. 5 times 2 is 47. All right, so the time, though, that's what we want. It's approximately 1.05. And that's question 17.